It's time for Alexander Lisachenko, and he will talk about escaping from OOP boundaries. So let's hear it for Alexander.
Hello, everyone. It's so awesome to be again on stage because it's several years when we cannot communicate, share our experience, and I really appreciate moments when we can communicate directly. Okay, today we will talk about some of existing boundaries which are present in PHP, limitations which defined by language. And the first part will be simple one, but the second part will be a little bit advanced. It will require a little bit knowledge of C language and internal PHP structures. Okay, let's go. I'm software architect currently at Docker holding company, which is famous for livejasmine.com site, and we are streaming a lot of video. I'm sharing my passion development by developing software by working with companies who are ready to evolve, who are ready to invent something really interesting, and this is why I'm also a good expert in enterprise architecture. And maybe some of you have seen already my library called Go OOP, which is aspect-oriented framework designed for PHP. If you're familiar with Java, AspectJ, or Spring frameworks, which provide similar functionality, you can switch then to PHP version of it. And of course, I will be happy to discuss more regarding aspect-oriented programming. Okay, first we will check what are existing PHP boundaries. Some of them are syntax boundaries, because we cannot, for example, use special constructions in language because just abstract syntax tree is not allowed us to do it, or PHP has internal definition how to handle such kind of opcodes. Then we will check how can we escape from such boundaries. First, we will check how to do it in a very simple way by using existing features, and next part will be a little bit interesting, because if you have good knowledge of C and at the same time you have good understanding what's happening on PHP side, then we can combine this knowledge into something really interesting and implement even a PHP extension in PHP itself. Okay. First boundary, which is really simple, is the open-close principle, and I guess it's very easy to understand that if our class is open for extension, at the same time it's closed for modification. And when we are talking about classes, it's very simple that if our class declared is final, then obviously we cannot create a child class, and if we will try to extend it, we cannot do it. But what to do in case if we want to mock our class, for example, if we are going to write a test code, and usually it can create some problems. And my question is it possible, what do you think, if it's possible to mock somehow final class? If you think yes, raise your hand. Yes, yes, okay. Only several persons in this place know how to do it properly. And for those who don't know, it will be interesting to see how we can do it. And the traditional answer, of course, no, because it's PHP, come on. If we create a final class, then obviously we will have this fatal error when we will try to extend it. And if we want to somehow mock it, we have several features provided by PHP itself. And first one is very tricky, but at the same time it's powerful. We have file stream handler inside PHP. And this file stream handler is responsible for all low-level operations with our files. If we're including file, if we're reading file, if we erasing file, all low-level operations are handled by this stream handler. And what we can do, we can temporarily unregister it and replace it with our own implementation. By doing this, we will have a full control over how our source code is analyzed and processed. And we can define our class, which will be responsible for checking every single place. And at the same time, we can do, for example, simple tokenization, find this final keyword in our code base, and simply remove this final keyword just because we don't want to have it for our test. And by doing this, our code will be ready to mock every single class, even final. And there are several libraries. One of them is, I guess, bypass final. And second one is patchwork, which provides such functionality. But it's really interesting to use this opportunity. OK, second escape, which is also present in PHP, is string filters. It's a little bit different comparing to our handlers, like file handlers, var handler. Filter is a special feature which can give us ability to transform our code in runtime by passing to a special filter. And here is an example. We have simple PHP file, and we can create a special version of include. You can see this special read string to upper, and this is specification how can we apply filter to our code base in runtime, and PHP will magically make our code uppercased. Of course, you can register your own filter, you can do anything you want, and I'm using this approach, exactly this approach, in my Go AOP library to dynamically transform your code base when we introducing additional behavior. For example, if you want to have all logging in all your public APIs, it will be just one single line defined in your aspect, and engine will do all the work in background by analyzing code, by checking what should be done, and by transforming it. We can do this. We can use this approach also for special kind of analysis. For example, we can scan our code base for potential bad places, and we can wrap them with special guards. So, for example, we can have special places where we're accessing public variables, and we want to sanitize them. With special filters, it's possible even to analyze your code base, find all problem places, and wrap them in runtime with protection code. Also, one interesting approach, which is still not implemented anywhere, is protection. If you're familiar with IonQ protector, this extension provides some kind of protection by encrypting your code base and distributing just opcodes of your application, not the source code directly, but just minified version which cannot be transformed back to PHP source code. And you cannot simply check what's happening in this application because code is protected. And of course, we can use this approach also for removal of final keywords, which is real simple. We can do runtime proxies, but it's another task. We are moving forward to more interesting features of PHP, and one of them is internal PHP structures. For every single class in PHP, we have this wonderful Zen class entry, and it has a special field called se_flex. And this small field is responsible for all attributes of your class. For example, if it's final or abstract, if it's interface or not. And the idea, what if we can somehow modify this flag directly from PHP? Maybe it's possible, maybe no, but I'm not sure right now. Let's check second boundary, which is defined by PHP. It's immutable PHP structures. As you know, PHP can be interpreter because we are defining our PHP scripts, and scripts are usually interpreted. But at the same time, PHP is also a kind of compiler because modern PHP has a lot of compilation phases. For example, if we running our PHP code base, first we need to parse it, which is kind of interpretation phase, but then we need to compile PHP code into something usable by engine itself, and this is compilation phase. So PHP is also a compiler. And then this compiled version of opcodes is executed by the end engine, and we are receiving some results like output from our controller, like HTML pages rendered. And on second run, we are not parsing our code again, but instead, we are just accessing opcodes directly from OpCache. And OpCache is very powerful because it's immutable, and even for new version of PHP, which is version 8, we can have several methods even compile it into machine version, which is just-in-time compilation. Let's check what's inside this OpCache. First, it contains some shared memory blocks, which is usually immutable. And this block cannot be changed just because we want to have very high, we want to have very nice performance of our application. And if some parts of this OpCache will be mutable, then we can have different problems like like attempts to change our structure in runtime from several processes, and definitely this be problematic. And the interesting point about OpCache that it can be only in append mode only. By doing this, Dmitry Stogov, which by default, which is author of OpCache, we can introduce additional guarantees that no one will reuse a previous part, or we will have some kind of garbage in our OpCache. Inside OpCache, we can have file functions, we can have definitions of our classes, we can have definition of our code itself, and I'm always trying to understand why it was created like that, because if you have an understanding what's happening inside this OpCache, we can define better performance. We can achieve better performance by, for example, moving reusable parts from our application, like strings or shared parts of our array, into immutable arrays and storing this special place in a special place in OpCache. And then you don't need to copy paste this part of block every time for your single request. You can just access it directly. But when we are talking about OpCache restrictions, it's easily to find out that this part cannot be changed in runtime. For example, we cannot add parents to our class, we cannot remove existing functions, we cannot redefine methods without specific features. And of course, it's very problematic to hijack PHP engine by accessing this memory. And of course, PHP was designed in a way to avoid random access to this memory. And when I have asked Dmitry Stogov first and then Nikita Popov during PHP Rust conference about my idea to access such kind of memory, Dmitry Stogov has replied, "Oh, looks like I have invented nuclear bomb right now. Please, don't do it." Anyway, it's possible to access with special extensions like runkit or user operations by CrackJoy, but it's still not possible to do some parts in our PHP code. Next boundary is language limits. Definitely we want to have this feature called operator overloading. Who really want to add two matrices or, for example, money objects? Do we want really to have this control over your hands? Unfortunately, PHP doesn't provide this kind of polymorphism comparing to C++, where we can easily define our own operator handler. But for PHP, we can do it only via extensions. And this is a very simple example what I'm trying to achieve. We have one matrix, we have a second matrix, and we have traditional rules defined how to multiply matrices, how to add them. But unfortunately, if we try to do this directly in PHP, PHP will complain. And before version 8 of PHP, this complaint is really strange. It's a PHP notice first, and second, we will have result like 3. What? PHP version 8 has improved this a little bit, and you can see this matrix type already in error message, and at least PHP has now better understanding about every single operand, thanks to Nikita, and we can finally have better results. We don't have any integer values returned from this expression. Okay, but what if we want to have this feature called operator overloading? And even it was requested by community in RFC, but unfortunately we haven't this RFC applied, and this is why we can do it on userland side. But it's possible to do it, for example, for datetime object. You can compare two datetimes, so at least we have some operators overloaded. Okay, switching to the interesting part. Now we will try to hack the PHP engine and check what's possible from current perspective. Our main tool is a foreign function interface, which was implemented for PHP version 7.4. And it allows us to call different C functions directly from PHP just by declaring C definitions. And we can use different C data types directly from PHP without even creating an extension. And also, it's very interesting to use this functionality to create PHP extensions. For example, some of you maybe knows how to connect to Kafka, and there is famous librdkafka extension, which is used heavily. So right now, we can do it directly from PHP side by using just foreign function interface feature. And also, there is one interesting feature to optimize our parsing of headers, and FFI has special function to preload all headers during startup of PHP application. And my idea, what if we will use PHP foreign function interface to access PHP itself? From one side, we have this PHP, and from second side, we have this foreign function interface feature. And I have implemented this that engine library, which is used right now for many hidden tricks in PHP. If you check it from very high level helicopter view, it will be just several of classes built on top of default PHP reflection. So if you are familiar with reflection, you already know that there is a reflection class. But if you check my library, there will be special functions like reflection class set abstract false or set abstract true. And this library has low-level bindings to all internal PHP structures like then class entry, then function, zval, and much, much more, which requires a little bit knowledge about how PHP is running in internal part. But what we can do, we can manipulate PHP in runtime. And of course, if you will try to do it, what could go wrong? Yeah, everything is expected, especially memory leaks, segmentation falls. But without fixing this, we cannot experiment, we cannot achieve new features. And this is why I really want to highlight that you shouldn't use this library on production for sure. Okay, let's return back to our first simple question. How can we make a final class a non-final? Do you remember this field which was previously shown? Now we can do very simple reflection class. We can access our final class and just call set final false to make it non-final. And what is really cool that from your perspective it's just natural feeling because it's reflection, and why not to call set final. And if we check result, PHP won't complain about any fatal errors like, oh, I cannot extend this final class because it's allowed. In runtime, we have just removed this final flag from our class, and now it's not final again. And if you open source code of library, then it will be just one single line, maybe, to update in runtime this particular field in the end class entry structure for this concrete class, and that's all. From this point, PHP class won't be final. And again, if you want to have this class declared as a final in runtime, we can just simply add this flag in runtime. But if we have such great power, what we can do else? Maybe we can create even PHP extensions from PHP. Come on, we are all developers. And what I want to give you is userland implementation of extension for operator overloading. I have implemented this library called native PHP matrix, and this library, as expected, built on top of ZEngine library, and it's first ever PHP userland extension. How it works? First, it tries to use special hooks which are available inside PHP itself, and exposes several handlers on PHP side to do all low-level logic. And for comparison of matrix, because I want to compare one matrix with another, I have also implemented additional hook to compare two different zeros. Let's go deeper in details. And we have this Zend object structure, which is representation of every single object in PHP. And if you check it, it's very simple. But there is interesting field in the structure which is called Zend object handlers. And it's pointer, constant pointer, unfortunately, so we cannot change it in runtime without special tricks. But inside the structure, PHP has a lot of interesting hooks which are available for configuration. And we can define our own handlers for a lot of different features available in PHP. For example, we can override how PHP will count our elements for object. We can override special tools like special hooks like do operation. And what we are going to do is to install our own PHP handler for this do operation handler. This hook is very simple. We have just OP code as an argument. We have a pointer where PHP is expected to return result, and we have first operand and second operand. If we check from PHP side, because I really don't want you to know all these low-level details, you will have this object do operation interface with a magic do operation method in it, which can be implemented by your code. And implementation for this library is very simple. We have this do operation method implemented, and we have PHP API provided by ZEngine library for us, and we can access simply first argument. We can check second argument. We can check which opcode is currently processed, and we can define our own logic how to handle every single OP code for our objects. Returning back to my previous example, now we have the same line, we have a library installed and running, and now, voila, finally we are able to define our own handlers for operators like plus, minus. We can override bitwise operators. It's possible to do from userland side. And the result is perfect. Next extension which I have created, immutable objects. Who was dreaming about having immutable objects in PHP? Raise your hands. Oh, cool. And why so small amount of hands? Okay. This extension also built on top of Z engine, and it hooks several handlers to prevent runtime modification of our objects by providing by throwing an exception when we are trying to access properties from outside of our object. And to implement this functionality, we just need write property handler. We need get property pointer handler, which is used for all indirect access, like when we're accessing property with indirect modification, like this field plus plus or this field, and trying to push a new element of array to it. And also we have this unset property, which is obvious if we are trying to unset field which should be immutable. And the implementation is very simple. In our field write handler, we are checking where we are trying to access this property. Is it outside of our code or from internal part? And if it's internal part, we are checking if it's constructor or static creator, static factory method. If not, then we are throwing an exception. And I don't want to give access for indirect modification of properties. This is why we have this throw new logic exception for field pointer access and field unset. Let's check how it works. We have our immutable class, which implements this immutable interface. And as you can see, we have public field called value. And we have initialized it with a hello, but then we are trying to write new value to this property directly, and the result will be fatal error. It's not allowed to modify immutable object in PHP just because we have overloaded all low-level handlers in PHP to prevent such kind of operations. And one more example what can be achieved with Z engine is shared objects. It's very known that PHP was designed to be sharing nothing. We are not sharing objects, we are not sharing a different kind of descriptors between our processes. Our PHP FPM has nothing common with another instance of PHP FPM running in the same pool. So it gives us ability not to worry about how our PHP is working, and we have nothing to share. It's easy because we can scale. We don't need to think how this particular part of memory, which by default should be shared. For example, in Java applications, you need always to think about how you would like to share your application between several running nodes. In PHP, we don't need to care about this. We can just scale it. Also, if our PHP application is failing at some point, usually it's just one single controller or action failing, and we can easily, even live with this on production, if we really want. But our remaining part of application will be working. And you don't need to know all this low-level stuff, which is usually known as IPC, inter-process communication. And it's another help because you need to know how to write mutexes, how to write semaphores, how to use them, critical sections, atomics, a lot of stuff which is really needed to implement properly this if you have something to share. But what if we want to somehow make our variable surviving HTTP request? For example, just a question. Would you like to have a Symfony container surviving your requests? I guess some of you who are very experienced would say yes, and we can use special tools like special engines like Roadrunner, like Svuli, which is famous in Chinese. And from my point of view, most of you would say no, because usually you don't need to care about such low-level features. But if we are talking about framework developers, if we are talking about developers who are creating some advanced tools like Roadrunner right now, most probably we need this feature. And if we want to start with something new, we need to somehow do it from a very unpopular way. And let's switch to one interesting structure again. It's a Zend model entry. And I guess I have found one interesting place in it which can be used for this. As you know, PHP has some kind of additional extensions which can be used by PHP code to implement additional features. And every single extension can define own memory. It can use it for advanced features. For example, if it's APCU, it can allocate memory. It can use it for sharing data between between processes. And my attempt is to somehow access this part of memory from userland by creating new structure, by writing to it, and check what we will have in the end. And my idea is to emulate how PHP was designed for extensions and reproduce every single step which is happening in PHP itself when we are trying to load PHP extension. And surprisingly, we have this solution right now. So what we can do from PHP side, we can create a new structure which is called Zend model entry, and we can initialize it with all necessary information about thread safety, with information about our model name, API version which is used by Zend. We can use debug flag if it's enabled, and if we want to have our custom shared area of memory, we can use allocation of memory available in FFI, and we can also define it as a persistent. In this way, this particular area of memory will be preserved between requests. It's very important to understand that PHP has two independent memory models. One of them is traditional one, which is usually collected by PHP, and the second one is persistent, which can be allocated by FFI, and we will be responsible for deallocating it. And then we can call this Zend register model X function to emulate registration of our new model from PHP inside PHP itself. And then we only need to call one more Zend startup model X function to make it running. And now we have running PHP extension defined in PHP itself. And what we can do, we can use special model registry variable, which is exposed by PHP. And this variable contains links to all your internal structures for Zend model registry. And we can find our own record in this table. And inside this table, we can access this globals underscore PTR field to find our memory between requests. So it's like our notebook where we have recorded pointers. First one is we have model registry. We are looking for our extension. We have pointer to it. And then we can use pointer to our own memory, which was previously allocated. And now it's only our responsibility to use this memory properly. I have created one more simple library called PHP shard data extension, which is also built on top of that engine. And it's a very basic implementation of first ever PHP model written in PHP. And it's just simple counter which can be persisted between requests. So what I'm trying to do is to create an extension which will have just 10 integers allocated for me, unsigned integers. And I'm trying just to do increment during my request and to check what's happening if my request will be running or not. And after several requests, we'll have this wonderful picture. So as you can see, numbers are growing, but we do not initialize somehow values for every single request. They are growing just because memory is shared and we can reuse this block again and again between requests. But what if we want to go deeper? On the very high level, we have this C, C++, Java, PHP languages, which are traditionally languages, high-level languages. And we want to go deeper, and we want to access maybe assembly language or even maybe machine language. Why not? Let's go. For this, we can create a special area in our memory, and we need to make it available for execution. This is why we have special magic numbers for mmap call, which is system call used by Linux kernel to allocate special memory. And then we can create then internal function structure with all information inside it, like that it's internal function. We have 0 arguments. We don't have any required arguments. We don't want to provide information about arguments, which is used by reflection. We want to have this function as public, and we have handler which is initialized to our raw code. And what I'm trying to do is to find my class, find its method table, and just insert this in runtime. I have created a small example with, which just outputs hello world in assembly language. This code will be not portable as expected, so don't try to run this on different platforms, because on macOS it will be different, on Linux it will be different, but still this is how we can create code from PHP which will be run directly on our CPU. And then we can just define it, create a reflection, and call an internal method to our class. And then we can just in runtime call this new method created in runtime, and we will have hello world. How cool is it to run assembly from PHP? And I guess it will be really interesting to improve this library and use it for for new PHP features. And during our discussion with Dmitry Stogov, which is one of core contributors of PHP, he has even shared ideas that with this extension we can have a new way to create extensions in PHP and replace our outdated PECL extensions, which is not maintained right now. We want to have something instead of this. And also we can have very powerful extensions with a very good speed, for example, for machine learning, for accessing hardware. So I guess a lot of interesting can be expected. And what I want to achieve is stable API first, which can be used without any SIG faults. I want to have some tools provided for OP code manipulation, and especially this part will be interesting for aspect-oriented programming, because I want to read the code, compile it into binary version, and just give it to PHP itself. So we don't need to parse PHP code at all and make it running with binary version of our application. Also, we can implement late shared objects. This will be shared Symfony container, which will be persisted between requests without serialization, without deserialization. I'm really looking forward to this because it's really interesting to have, for example, database connection persisted between requests, objects persisted between requests, and then we can reduce our overhead for initialization, overhead for connection, etc. And I guess that's all. Thank you very much for listening.